My name is Jingjing Wu, and my colleague Cynthia Henry and I will run this session together. And I think we can wait for other people to come in while we are talking. So we will record this session as editing transcripts takes time. So the recording will be available next Tuesday or Wednesday. Yeah. We appreciate you took time filling up the pre-survey and evaluations. Our workshops focus on the data processing and visualization. So for statistical analysis, we mentioned a little about descriptive statistics, but not something like verifying hypothesis or t-tests or linear regression. So if you are specifically looking for using R for statistical analysis, I added 2 books in the guide. So could you see the guide? Okay, so it's under the section books and videos. I add these 2 books. Discovering Statistics Using R, and another one is Modern Statistics for Modern Biology. Those 2 books, unfortunately, we don't have them in the library, but you still can use our document delivery service to borrow them from other libraries. Again, if you have any questions, you can type in the chat box or unmute yourself and speak up. So now Cynthia starts the recording.
Good.
Okay. So, last week, we installed RStudio and a package Tidyverse. We created an RStudio project. We named it as R Workshop Spring 2022. We also talk about basic concepts like object, function, and vector. We use a vector to refer to atomic vector, which is composed by elements of the same data type. So we saw examples of numeric vectors, character vectors, or integer vectors, and logical vectors. For numeric data type, we know they are numbers. We also use the term double for numeric data. Actually, double is the term used in programming for data type. It describes these numbers from another angle. So let's say precision and memory usage. Comparing with double, there is another term called float. I could not remember exactly if a number, let's say of float type, takes 4 bytes of memory and has 7 to 8 significant digits. A number of double type takes 8 bytes and has 15 to 16 significant digits, which means the higher precision, the more memory space it takes. R does not use the term float. It uses double, and double is interchangeable with numeric in R. We don't have time to cover missing data. So this time we will start with missing data. So in the real world, it's not uncommon to see missing data in our research projects. As R was designed to analyze data sets, it includes the concept of missing data, which most other languages don't. In R, we use NA to represent missing data. If our data include missing values and we want to do some calculation, and most functions will return NA. So this feature kind of make it harder to deal with missing data. But in R, there are ways to ignore missing data. So we will see some examples first. If you want to code along, you can open the RStudio project from last week. And I think I have my on the desktop. And the file is R workshop spring 2022. So when I open this file, I open it in RStudio. Okay. Okay. So we know under files, we have the folder scripts. And last time we create the R script, day one introduction to R. And we can open this and continue coding. This time we're going to talk about missing data. So first we're going to create a section. We use Control-Shift-R and we name this section missing data. So we see this new section created. And I think we can fold previous sections. So first, we are going to create a vector with missing data. So we name it rooms, and we use Alt minus or Alt dash, and we create a vector using the function C. So this is number of rooms is 2, 1, 1, NA, and 4. When we hit Control Enter, we see this vector created in the environment. If we want to calculate the mean of rooms, we use the function min, and we put rooms, and then we hit Enter, we got NA. And if we try to find the maximum number of rooms, and we got the result NA. In R, let's say the functions min and max, both of them have arguments. It's called NA.rm. That's kind of remove NA. By default, it was set as false. But when we set them as true, when we change it as true, let's say min rooms and NA.rm equals true, and then we get the result 2. See how this 2 is kind of calculated out. And so we see rooms has 5 elements. And when we remove NA, we have 4 elements left. And when we sum up the 4 numbers, 2114 is 8, divided by the number of elements 4, we got 2. And the same for max and rooms, and we add NARM and we set it as true, and then we find the maximum is 4. R also has some functions dealing with missing data. And is NA is the one used the most. It returns a logical vector indicating which element is missing. So let's try is NA rooms. And then we got the results. The first one is not a missing data. The fourth one is. So the fourth element is true. We may sometimes want to remove missing data. So we can use the function is NA. Let's say last time we kind of talked about the subset vector. We can use the single square bracket to subset. Let's say is NA. If we kind of write like this, the only elements kept will be NA. We don't want it. We want all the elements is not NA. In R, we use exclamation for not. Okay. And then now you can see we got only 4 elements which are not NA. We may want to count the numbers of missing values. We can also use is NA. This one will returns the results like this. And if we sum this true or false up, when we kind of total them up, we get, let's say, false is treated as 0, and true is treated as 1. So when we sum them up, and we will get 1. We have only 1 missing data. There are some other functions handling missing values. For example, other functions. NA omit. It will remove the missing value, remove NAs, and complete cases. If you are interested in learning them more, and you can read the coursework or the help document. To read the help document, you can use, let's say, help function, or you can simply put question mark in front of a function. So you run this, it will returns the help document here in the help tab. So next, we're going to do an exercise. So I'm posting, first, we are going to create a new vector. It's also called rooms. I just copy, it's kind of long, and I will paste it here in the chat. So this is the vector we're defining. So run that. And then I have 3 questions for you. Okay. I put the questions here. And then I make them, commented them out. So first, remove NAs from rooms. The second, I want the median of the rooms. And the third, how many households in this set use more than 2 rooms? I will give you 2 minutes. Okay, it's kind of around 2 minutes. So we will talk about the solutions. For the first one, we kind of already do that using the
We do have a,
function. Oh,
I'm sorry, we do have a question in the chat if you wanted to address that as well.
okay.
Somebody is saying that they're getting an error object and A not found.
What is the code?
Yeah, so maybe if
It was the code of assigning rooms, just what you had pasted in the Zoom chat. For some reason, when I put that in,
So when you
and
paste
that-
it, did you notice NA become it's kind of bluish? Oh, okay, all the elements are blue, right?
okay,
yeah,
If you change and you type in NA.
okay, I capitalized it.
Oh yeah, you need to
didn't-
capitalize it.
It didn't happen on its own. I thought that I saw that it did it. It changed it automatically at some point.
Okay,
Okay, I fixed that. Thank you.
okay,
okay, go ahead, Jing Jing then.
okay. So we already know we can use is NA. So for question number 1, we already know we can use is NA to find out the NA, find out the missing data. And so, okay, and we can use the square brackets to subset all the elements is not NA. And we want to assign them into rooms, no, NA. And then when we check rooms, no, NA, we will see all the NAs are removed. So question number 2, medium of rooms. So we know that medium and then rooms, we need to remove NA. We use NA.rm equals 2 to remove medium. Oh, rooms. Then we got the medium 1. For the question 3, how many households use more than 2 rooms? So first, we need to make sure we remove all the NAs. And then we will figure out which elements is greater than 2. And then we will find out how many. So this kind of 3 steps. The question number 1, we already kind of removed NAs, so we can start from there. So to keep only values greater than 2, we can use the square brackets to subset. Okay. So rooms, no, NA, and then we subset rooms, no, NA greater than 2. We will assign this to rooms above 2. Then we can take a look. So we see 4 digits, 4 numbers. And we want to know how many elements in this new vector. We can just use length. then the result is 4. So there are different ways to do that, but this is kind of the step-by-step, 3-step solution. Do you have any questions? If you are still with me, please click the green check mark under interaction.
So we only have a few there. Even if you want to give us a thumbs up or you're good. Or if you need to ask a question, feel free to do that. Okay, we're getting a few more. I think they just had to find it. So yeah.
Or you can just type in the chat.
Yes, we got a few there as well now.
Okay. So, I'm going to move forward to the today's kind of the session 2 content. And first thing, we are going to save this file and close it. And for the session 2 content, we're going to talk about data frame, factor, and dates. So first, we're going to talk about the data frames. In R, data frame is the data structure for tabular data. The most common tabular data are CSV files, or Excel spreadsheet, or Google Sheet. So first, we can take a look. This is a simple example of data frame. So we see 3 columns in 3 different colors. So the first column has 3 elements. All the elements are numbers. So it is a numeric vector of 3 elements. The second column, that's a character vector of 3 elements. And the third column, a logical vector of 3 elements. In a data frame, data are in the format of a table where the columns are atomic vectors of the same length. Data frames can be created by hand, but we usually read a data set or a spreadsheet into R using commands. Before we get our hands dirty, we can take a look at the data we are going to use today. So the data we are going to use is the data we downloaded last week. It is a survey data. The topic is called SAFI, let's say starting African farmer-led irrigation. So the study looks at the farming and irrigation method in Tanzania and Mozambique. The data was collected through interviews covering household features or agriculture practices, assets, or details about the household members. And the data we're going to use is only part of the interview responses. It is a CSV file. We already know that. It contains 14 variables or 14 columns. Here you can see the name of these 14 variables. And the description, it shows you what it is. Also, we can make some guesses. Let's say key ID. So we may guess it can be numbers, and also it can be characters. villages, it must be characters. And interview date, it can be date and time type, or it can be characters. So when we open this file, CSV file, you will see a sheet like this. And so the first one, the key ID, we see all the numbers, and the village, we see all the character. And we also see some nouns. I highlighted them in yellow. So nouns here in this data set, it means missing data. We just learned in R, NA is used for missing data. So maybe we can do something when we read data into R. So now we are ready to play with this data set. So back to here. And we are going to create a new R script. So creating a new R script, we can use this icon. Oh, let's say we create R script, and then we save it to scripts, and then we can name it, let's say, A2, and start with data, and we save it. We will see a new file added. Okay. So first we want to add some information about this file. So we're going to say title, this data, and author, you can put your name here, and you can put date. It's today's date. I think it's January. Then we add a new section. It's called RB data. Okay. And first, we're going to load the package tidyverse. We know tidyverse is a collection of packages, and we installed tidyverse last time, but every time we want to use it, I mean every new R session, and we need to load it. To load it, we use the function library. It may take a minute to load it. Okay, you can see in the console, and we see this is the kind of the results. We see several packages, several libraries are loaded: ggplot2, tibble, tidyr, readr, and also we see some conflicts. So we see the first one, dplyr. We can see that both dplyr and stats have the same function filter, but they have the same name, but they are not really same functions. They function differently. But when we kind of load tidyverse, and the filter in dplyr masks the one in stats. If you want to use the filter function in stats, you need to put stats : in front. Okay. And if you have not download the file, I mean the data, you can use this command to download it. But first you need to create the RStudio project, and also you need to create the folder data. So you can see, let's say I can put it here, but I will comment it out. So you can see we use the folder data here. And this is the URL where the file is. Okay. We already have the file, data file in our project. And then next, what's going on? Okay. Next, we'll read them into the R environment. Okay, so we know it is an interview data, so we name it interviews. And then we use the function read underscore CSV, underscore CSV. And we will read it from data. And the file name is clean.csv. And we know in the data, in the CSV file, we have now NULL as missing data. We want to replace it with NA. So we use NA equals to NULL. We put now into quotes, and then we run it.
You have a mistake in clean and you have an R there.
Oh, okay, thank you.
Sure.
Okay, so we see we have a new object generated here. And also we see in the console, we can see rows and columns. We have 131 rows and 14 columns. We also call rows as observation and column as variables. So among those 14 variables, we have 7 character variables, 6 double variables, and 1 date and time variables. I think it's in the evaluation form. I saw some people say they want to work on Excel file. The function read underscore CSV could not open the Excel file. So if we want to open an Excel file, you need another package. The package name is readXL. It is also a tidyverse package, but it won't load automatically while we are loading the tidyverse. So anyway, you can find it here, read. So we can scroll down to our readXL. You can use library to load it. And the function, okay, this is the package name. And the function we're going to use to read a CSV file is Excel file is read underscore excel. That's the function. And you can practice it after the workshop. You may notice when I type in read CSV, and it kind of pops up this small windows with a list of functions. The first one is .csv, but we didn't use it. We used the one underscore. So what's the difference of these two functions? The read.csv, that's a function in the package utils. And the underscore CSV, this is the one from the package read R. And when we use the .csv, it coerces the column name with space or special characters to a different name. Let's say if we have a column name, interview space date, it will become interview period date. So it's kind of rename it. And also if we use the .csv, it will store the data as a data frame, while the underscore CSV will store the data as table. So what is a table? Table are data frames. So, but some people describe them as a lazy and surely data frames, which basically means they do less than regular data frame. Functions in Tidyverse works well with tables. So we will use tables in our workshops. Some functions beyond Tidyverse may not work with tables. So when you use those functions, you have to convert table into a data frame. The function you will use is, let's say, convert the regular data frame. Let's say you can use as data frame to convert a table to a regular data frame. And also, if you want to convert to a table, you can use as underscore table to convert a regular data frame to a table. So we have imported the data sets, but we haven't taken a look. To view the data sets, we can just simply use the name of the object.
Oh.
And then we will see in the console, the first 10 rows are listed and some columns are here, but other columns may not. It kind of depends on the size of your screen. Let's say if I expand and run it again, and I see 2 more columns displayed. And another way to view a data frame is we use the function view. And it will open a tab. And we see the whole data set. last week, when we talk about vectors, we use some functions to inspect vectors. And we use the length to see how many elements in the vector. And we use str, which is kind of the short format of structure, to see an overview of a vector. And this time we're going to inspect the data frame. So first we want to see the size. The function we're going to use is dimension. So we can see we have 131 rows and 14 columns. If we specifically want to see how many rows, we use the function nrow, and we got 131. The same n column will get us the number of columns. We can also see the content. The function we're going to use is head. So it displays the first 6 rows. And we can see it is a table. The first 6 rows, it kind of make a table. And then it has 6 rows and 14 columns. Another one is tail. That will be the last 6 rows. Actually, both head and the tail has argument n. It allows you to specify how many rows you want to keep. Let's say we want to see the first row. We can use interviews and n equals to 1. We see only 1 row. Even it is only 1 row, it is still a table. It is a 1 by 14 table. And if we want to see the last 3 rows, we can set n equals to 3. So we see the last 3. Other things we want to learn about a data frame or a table can be, let's say, the names, column names. The function we can use is names. And then, so we see all the names are listed here. But this time we did not get a table. This is a vector. This vector has 14 elements. So this is the first element, 1, 2, 3, and this is the 4th. And 7th, let's say this is the 14th. And also we can see a summary, an overview of the data frame. We use the function str, structure. We use that for vector. We can also use that for data frame or table. So the function str returns the class. I think this is the class, and the dimension, I think that's the kind of the size, and also returns the contents. These are the data type. Another one function we can use is summary. It returns the statistical summary of each column, of each variable. If a variable is numeric, it will return kind of like minimum, maximum, mean, median, and the quantiles. If it is a character, it will return the length, how many elements, and the class and mode. Mode is kind of like type. Another function we can use is glimpse. Glimpse. It kind of returns similar stuff. It shows the rows, how many rows and columns, and it's kind of in different format. And glimpse is a function of tidyverse. So we have to load tidyverse to use glimpse. So sometimes we don't want to use the whole data set. We want to use only part of it. So that's subsetting. And now we're going to talk about subset. Last week, we used the square bracket to subset a vector by index or on certain conditions. To subset a data frame, we still can use the single square bracket. And there are other two symbols we can use. One is double square brackets. Another one is $sign. We will talk about them one by one.
Could you say again, please, what the subsetting was available for in the single bracket? You said it could return two different things.
Oh, it's not return two different things. We can use index, that's the number. And we can also use conditions. Let's say, is that, did I answer your question?
That was what I had not gotten copied. Thank you.
Okay. So first we're going to talk about the single square bracket. And we're going to use the single brackets, single square brackets and index to subset data frame. Different from vectors, data frames are two dimensions. So it has rows and columns. And so the index of a data frame contains two numbers. First is for rows and the second is for columns. Both indexes start from 1, which is the same as the index of a vector. Let's say we want to take a look at the first element of the first row. So we can use interviews one and one. When we hit enter, we see the readout here. So it is a table. Even it has only one value. It is a table. It is a 1-by-1 table. And we see the column name is key ID, and the data type is double. So if we want to see the first element in the 6th column, and we can use interviews, kind of like element in the 6th. And also, this is a 1-by-1 table, and the column name is respondent word type, and it is a character data, and then the value is Madao. We can get multiple elements. So let's say we want to see the first 3 elements of the 7th column. Still want to go back using this interviews and the first 3 and the 7th column. So this is a table, 3-by-1 table, and the column name rooms. It is a double, it's a number, and we see the first 3 elements are all ones. The colon operator, it is a range. It's kind of like it's a series of numbers in sequence, and it can be increasing, and also it can be decreasing. We can use 1 through 3, and also we can use 3:1. But in our case, that will be the same results. We can also use the single square bracket to kind of subset a column. Okay, so first we talk about rows. Okay. Want the 3rd row. Third row or the 3rd observation. So here we start with, we know it's the 3rd row. So the first number will be 3. And the second number, the column number, we're going to leave them as blank. And then we will get a 1-by-14 table, and we see all the column names on the top and the values for the 3rd row are listed here. We can also get multiple rows. Let's say we want the first 6 rows the same. This is actually same as the function head. Can put this here. Next, we're going to talk about columns. If we want the first column, we will leave the row blank and we put 1 here. So this is 131 by 1 table, and we see the first 10 elements displayed. When we subset the column, we don't have to have the comma. We can just put the number 1 here. We get the same results. You can see this is no comma and this is with comma. So last week we used the minus to exclude elements from a vector. So the same, we can use minus here to exclude certain rows or columns from a data frame. So let's say we want to see the whole table, the whole data frame, except for the first column. So we can use comma -1. It is the same as interviews -1. So this is 131 by 13 table. And it starts with village instead of key ID. We can also use minus to exclude rows. So let's say interviews, and we don't want the rows from 7 through 131. We got this 6 by 14. It is the same as we already know we have 131 records or 31 rows. And if we don't know, we can use the function enroll. And then we still want to remove it. Exclude them. Okay, let's start with we want to exclude them. They are the same, equivalent to the function head. So we just saw the data frame or tables can be subset by calling indexes. Also, we can subset them using the names, column names. And we know the second column, the name is village. So we see this village column only. So the single square bracket, we can use that. We can using the let's say index, and also we can use column names, and they will return a table. Okay. Next,
Could I ask,
oh, excuse me.
could I
Yes.
ask one question? Actually, I think I got what we did on line 60 was we were returning a set except for something, right? Okay.
Yeah.
Okay. I had a question that I think that's the answer to. Thank you.
Okay. So we exclude the rows from 7 to 131. Okay.
So that if you scroll back up, you would only see lines 1 through 6. Do you see that, Brad?
I'm sorry.
So if you scroll back up in her console area, you would only see the lines 1 through 6 when we ran
Yes.
that. Okay.
Yes.
Oh, so next we're going to talk about the double square brackets. So still, let's say we can use that. Still, we want the first element of the first column, and then we Control Enter, and then we got the number 1. But we also notice it is not a table. It is a vector. Let's say we can also use double square brackets to get a column using the column using the column index. If you're already tired of this numbers, and we can try villages. How do I know it's a vector? We can use is tag. Then it will return true. And if we want to see is a data frame, it will say false. The same is table, it will be false. And also we can use the column name. So we use village, and then we got the list. I mean, we got the vector. For the third method, the $sign. You can see a quick example. We know we can use the column name, and then we see the result. It is also a vector. Okay. So here is kind of a quick takeaway. So we talk about data frames or tables. We use the function read_CSV to read our CSV files into our environment. And we use some functions to inspect data frame. We kind of check the size, the content, the column names, and the kind of some summary or the overlook of a data frame. And we subset a data frame using single square bracket. We get a table, and we use double square brackets and $sign. They all come with the results will be vectors. So it's kind of already over 3 o'clock. Could we just continue, skip the break?
What do y'all think? Does anybody have a preference? They're saying either, so.
Okay. Okay, so I will go ahead. If you want to take a short break, please. And yeah, I will talk about the next topic, factors. So first I'm going to create a section called factors. And factor is a special vector in R. It is used to handle categorical data when doing statistical analysis or creating plots. The categorical data can be numeric or characters. So here are the two major differences between a factor and a vector. We know factors represent categorical data, but they are stored as integers. So factors look and often behave like character vectors, but they are actually treated as integer vectors by R. Once created, factors can only contain predefined values. We know them as levels. By default, R sorts levels alphabetically. So first we can create a simple factor. The function we're going to use is called factor. And so this is the factor. Let's say we have earth and we have cement. And we have another cement and another earth. Okay, so we are going to name this object respondent floor type. So now it is a factor. We can check it. Use is factor. We get true. So when we create this factor, R assigns 1 to cement and 2 to earth, because C comes first, comes before E. Even our first element is earth. We can see that by using the function levels. So the first level is cement and followed with earth. If we want to check how many levels in a factor, we use n levels. So we got 2. And also we can just simply type the object name and run it. And we can see not only the elements, and also we can see the levels. We know that in R's memory, factors is stored as integers. Cement is 1 and the earth is 2. We can tell that by converting the factor into a number. We use the function as numeric, and then we see 2, which is earth, and 1 is cement. So when we have a large amount of data, but with limited unique values, a benefit of using factor is saving memory space. All the elements are stored as integers. Factors have another feature. They can only contain predefined values or levels. So if we add a new value beyond levels, we will receive warning message. Okay, so we can see an example here. Let's say we already know respondent floor type. We know our third element is cement. But now we want to assign it as brick. When we run it, we receive this warning message: invalid factor level, NA generated. So we can take a look at the new respondent floor type. We still have 4 elements, but the third one is replaced by NA, and the levels are still 2, cement and earth. Could we add a new level? The answer is yes. The function we use to add a new level is levels. We just use this function to check the levels of a factor, and we can also use levels to add a new level. So let's say respondent wall type, we assign that to then we add a new level at the end, break. So we assign this new levels to the factor respondent wall type. Now we can take a look at the our current object. Okay, let's say in here. You can use the previous, in the console, you can use the previous command, use the upper arrow. So this one I can check. Still, we have the NA in the object, but we have a new level added. And if we run this one, we replace NA with brick. Let's see it. And then we take a look at the object. So NA is replaced by brick. Now we understand what a vector is and what the difference between a vector and a regular vector. Why do we want to use integers to represent categorical data? We just mentioned one advantage is saving memory space. And I'm going to show you more examples why we want to use factors to, integers to replace kind of represent categorical information. So first, we're going to see example 1. We can reorder categorical data as we want. Okay. So first, we're going to define a regular vector. We call it R1. Basically, it's a ranking. So we use the function C. We have medium, and we have high, we have very high, we have low, very low. So this is our new object R1. If we want to sort it, we see the results. It is sorted alphabetically, but that's not what we want. We want it to be kind of from very low to low, medium, very high, and very high, or the opposite direction. But we can do that using the factor. We already use a factor to convert a vector to a factor. Factor kind of has more than one argument, and it has one argument it's called levels. So the levels contains all the unique values in a vector. But by default, the levels are sorted alphabetically, but we can specify the order of these values using this argument levels. So first, we can define a ranking. Let's say we call that ranking levels. And we define it as very low medium and very high. So this time we're going to create a factor using the function factor. The vector we're going to use is R1, but we are going to use the argument levels. The levels we are already defined, that's ranking levels. Now we can take a look at R1 factor. We have the levels from very low to very high. And if we sort it, we will get the elements sorted from very low to very high. So we can use factors to easily reorder the categorical data the way we want. Other examples can be, let's say, months. We want to it ordered like from January to December, all the dates from Sunday to Saturday. in some survey results, we have opinion levels from strong disagree to strong agree, and yeah, we can reorder them the way we want. So next, I'm going to show you another example. We use that factor to identify typos. Still, this time we're going to define the object or a vector R2.
I have a typing question.
Uh-huh.
Since when you initiate a quotation mark, it already puts the second. You can type the word. Is there a fast way to start typing the next word, or do you have to always push the arrow to the right to move beyond that second quotation mark and then place your comma?
The second quotation mark, I didn't really, when I just key in the quotation mark, it will automatically have the second quotation mark.
Okay, so you go ahead and type that quotation mark even though it's already there, and it defaults to accept what you did and not replicate. Okay.
You don't have to
I
type
see.
the second one.
You don't, but then you have to move beyond it, move beyond that default. If you do, you still have to hit a key. You have to get some kind of key to move beyond it, right?
Right. So do you use the arrow to put the comma in, Jing, after you're closing this? How do you get to that point? How did you
just use the space?
You just use the space. Okay. I have been using the arrow too, Brad.
I always think I type, too slow. Okay. Anyway, this is the we define the second, the R2, the object, the vector, and with typos. Okay, and then we will create the factor, and we are going to use the factor and then R2. And for levels, we're going to use the same ranking levels. And when we take a look at factors, and we may notice, the second element is missing. That's NA. And the last one is NA. When we take a close look, we know, you spell it wrong. And this should be the uppercase L, and I use the lowercase. And another function can help us more to kind of specify the arrow. And R2. Okay. And then you can just copy those. They are the same. And then this time it specifies the second element. This is what I type in. And the seventh, this is low. Okay, so we can use factors to avoid or identify typos. The third example, we're going to talk about the reasons why we want to use factors is we can use factors to merge levels. So we're going to use the same kind of vectors we created. We are going to use the, okay, I'm still going to create R3 factor, but I'm going to use it same as the R1 factor. And when we take a look at R3 factor, it should look familiar to us. That's the one, and we already have them. We have the levels set up. In the previous two examples, we have the factors have 5 levels. We may think it's too much to manage 5 levels. We want a matrix of 3 levels. We want them to be low, medium, and high. So to do that, we can use the function levels. This is the third time we use this function. The first time we use that to check the levels. The second time we use it to add a new level. And this time we use it to merge levels. So R3 factors. And then we still going to have 5 levels, but we will use low to replace very low. And to high to replace very high. Then when we take a look at the factor, we see that very high and very low are replaced by high and low, and the levels, we have only 3 levels. So there are kind of some advantages to use the factors. And in the coursework, there is another one. You can use factors to improve visualizations. And you can take a look at there in the coursework. So now we want to do an exercise. We talk about levels. We use the function levels 3 times. And also we kind of talk about the levels, the parameter, the argument levels in the function factor. So, okay, so we want to, okay, see, we want a quick exercise. Let's say we want to rename levels, and okay, so first, this time for this exercise, we're going to use the data from the interviews. Okay, we are going to use the interviews. Okay, this is kind of complicated. Okay. In the interviews, there is a column, it's called member associate. And it kind of check if a respondent is a member of an irrigation association. It contains only values yes, no, O, and A. And this, okay, this is the one this is the column name. Now we kind of extract this column and we name it as member associate. And then we can convert it to factor. Okay. So, okay. Now we have this factor, and we can do our exercise. Oh, first, we can take a look. Sorry. This is the data. So we have NAs, we have yes, and we have no's. But we have, for the levels, we have only two, yes and no. Oh, no and yes. And if we want to kind of rename the, so the first exercise is rename levels to this is the question. Rename the levels to have the first letter in uppercase. Currently, we have no and yes, so we want it to be no and yes. The second question is, currently the order is no comes first. We want yes comes first. So basically, this exercise is kind of help you to understand the function levels and the argument levels in the function factor. To do that, for the first question, we want to rename it. We can use levels. That we use the function levels. And then we redefine it. I mean, no and yes. So when we take a look at the factor, we will see no comes first. Oh, it is, okay, sorry. No is kind of the first, no, N is capitalized and Y is capitalized. If we want to change the order of the levels, we're going to use the argument levels. And levels, we're going to specify yes first, and then follow with no. And this time when we check, we will see it changed. But the data has not changed. Yes, it's still yes. Okay. So if you don't have any questions, we are going to talk about dates. Date and we can create a new section. Date and time information is quite common in research data. So a good practice for dealing with dates is to store each component of the date as a separate variable. Why? First, because of the regional differences. So we can specify the time zone in the documents. And the second, different software formats and stores dates differently. Sometimes we have incomplete dates. Let's say we have year and month only. Maybe we have month and date only, but missing the year information. In our data sets, we have a column called interview date. It contains the information about the year, the month, and the date when the interview was conducted. So we can convert those dates into 3 separate columns. So the package we're going to use is lubricate date. And it is a package in tidyverse, but when we load tidyverse, it's not automatically loaded. So we can check, let's say, lubricate LM. Why it is not here? Let's say we can use library to date.
I don't think that's spelled right. Do you think it is?
Yes,
You do. Okay.
yes, I think it should be, but I think it should be somewhere here,
I see.
but I didn't see it. Anyway,
Let me look.
so first we're going to get the data from the interview. So we will define a new vector. It's called dates. And then we subset it from the data frame interviews, and the column name is interview date.
I found it, Jingjing. If you want me to help you locate it, it's above where you're looking. Go to the upper one to the alphabet. Yeah, the next one up. There you go.
Okay, this is system library.
Yeah, here it is. It's above there.
Okay, yeah, here
There
it
it
is checked because we just loaded it. Otherwise, it will be unchecked.
Yes. Okay.
So, so we can take a look at dates. And then we see all those elements. And also we see UTC, which is basically coordinated universal time. That's the Greenwich Mean Time. And we want to separate them into day, month, and year. So we are going to use, we are going to call them day and the function we're going to use is called day. Okay, so we will finish the 3 columns and then explain them together. So we add 3 columns to the data frame interviews. And now you can see from the environment, we have 17 variables, 17 columns. And also we can see that from the tab. If we, it should be there. Okay. Let's see if I save it. Oh, let's run this. Let's run this function. Then we have these 3 columns added. So when R read our data, the interview date, this column was read in correctly as a date variable. But not everybody gets the luck as we do. Sometimes dates are read in as character variables. We need to use the function as date to convert them into a proper date format. Okay. So here we see another example. First, we are going to define a character vector. And then we will use the as date to convert this new vector. As date has an argument, it's called format, and we have to treat it very carefully. We know the first this first number is month and date and year with kind of 4-digit year. So we will use this format like M, D, date, and percentage Y. This is the uppercase Y. When we run it, we got the date information, and this is exactly date we expect. Let's say if we use the lowercase y, we will get something different. It seems like the month and the date are the same, but the year looks different because the lowercase y means 2-digit year. So it will use the first 2 digits, make the year. And even worse, if we kind of use the wrong direction. I should use Y. And let's say this is D, this is M. and then we will receive 2 missing data because there's no month 31 and no month 30.
I'm sorry, can we pause for a bit? I'm getting an error that's causing me to get no data as I'm trying to call up these dates. I'm looking
which
through my
code?
code to figure out what's wrong.
Could you put your codes in the chat?
Not very easily. My Zoom is open on a tablet and I'm working on a different desktop.
Okay, so which line? 130.
I think he just needs a second to kind of look at yours and look at his. Give him a minute where he sees the mistake.
Okay.
Okay, I've got it. Thank you.
Okay.
Okay, so another function we can use is that's kind of not one function, that's several functions, 3 functions is mdy and dmy and ymd. We can use these functions to do the conversion, convert a character to a date. Let's say still this one, as we know, this is month, date, and year. So we will use mdy, and then we convert character, date, and then we see where am I? Oh, okay, I know. I did not get the, okay, run this again. So we get the exactly same results as this correct version. So we got the same results. We can also kind of, let's say, use, say if we have dates like January the 1st, 2010, and we know it is mdy, and then we can use that to convert into this. And even we have kind of complicated format, let's say August 19, and we put the year into
Parentheses.
Parentheses, yes.
You got it.
And then we have mdy. Oh, all of those are mdys. I should show an example of something else. Let's say we have year and month and date. So we can use year, month, date, and it converted to 2015, March the 7th. So
And
this
we're in 10 minutes out.
Yeah, this
Okay.
That's the end of this date section. And we have a quick takeaway. And we talk about the factors, and we especially we talk about the function levels, and we can use that to inspect a factor, and also we can use that to add new levels or rename levels. And we use the function factor to create a new factor, to convert a vector to a factor. And it has argument levels. We can use levels to reorder the levels. By default, it will be ordered alphabetically, but we can use this to reorder it. We also talk about dates. A good practice is to store dates by each component, by year, by month, and day. And we can convert character vectors into dates. We can use the function as date. And also we can use these three magic functions, mdy, dmy, and ymd. And they are all functions in the package lubrate date. And we need to load it before we can use it. That's it all for today.